Okay, so as you may have realized, we are doing the same thing over and over and over again when we calculate the range, maximum height, etc. for a projectile. So we're going to make ourselves a calculator. So what we have here is an example calculator. So these numbers right here, the inputs, are things that the user of the calculator will enter. So for example, the launch velocity, the launch angle, which will be in degrees, the starting height and the ending height. So I might be solving a problem where the starting height is 25, the ending height is 0. It's launched at 50 meters per second at 36.87 degrees. So what your job is going to be is for all of these things right here, you have to write formulas to calculate them. Okay? So to start off, we're going to write a formula to find the angle in radians. The reason you have to do this is because Excel and spreadsheets speak radians. So to find the angle in radians, you'll start by typing equals. You'll click on the launch angle up here, so whatever the person types in there, and then you'll divide that by 57.296 is the conversion. So taking an angle in degrees and divided by 57.296 finds the angle in radians. So the angle is 0.64 radians. And the nice thing is, if the person then says they're going to do a different problem and the launch angle is now 60 degrees, for example, you'll notice that the angle automatically updates. Okay, so that's what we want. We want a formula to calculate the angle in radians. Okay, and so now what you need to do is write some more formulas. How would you find the velocity in the y direction initial? So you're going to write a formula using these values, things you've already calculated perhaps, the angle in radians, and if you need to, g or whatever, you're going to write a formula to find the velocity initial in the y direction, the velocity initial in the x direction. Delta y, which is pretty easy, that will simply equal y final minus y initial. And then here's where it gets complicated. You're going to have to write a formula to solve the quadratic equation to find the time based on delta y, the velocity initial in the y direction, and of course the acceleration due to gravity. Once you know the time aloft, you can calculate the range. To find the range, you will use the time that it's in the air and the velocity initial in the x direction. You can find the maximum height and the final velocity. So basically what you're going to do is take these equations we've been working on this unit and using over and over, and you're going to encode them in a spreadsheet so that when you are done, you have a tool which will automatically calculate all these things. So when I get all finished writing my formulas, here's what it'll look like. So here we go. I've put all my formulas in, and you can see that if I change something, like if I change my starting height to 0, if I type 0 here, delta y changes, the time aloft changes, the range changes. And so the idea is you're going to use these 4 inputs to calculate all of these things so that you basically build yourself a general tool that for any problem you can find the range, maximum height, and things like that. Now, to check and see whether you're right, you can go to one of your homework problems, put in the launch angle, the launch velocity, the starting and the ending heights, and you can see whether you get the same answers you got on your homework. A quick note, if it's a horizontally launched projectile, that simply means the launch angle is 0. And when you put a launch angle of 0 in, you will see that the velocity in the y direction initial, right here, is 0. So that's how you can solve horizontally launched projectile problems. Okay? Once you're finished making this and it works, then you're going to do a little experiment with it. You're going to set the launch angle to the velocity to 35 meters per second. Excuse me. And you're going to vary the launch angle. You're going to start at 5 degrees and get the range, 21 meters. And you're going to put that over here. So this is going to be 21.68. That's how far it'll go. And then you will change the angle to 10 degrees, for example, and look at the range. Now it's 42. So you'll put that in here, and you'll continue to fill this out as you go down. And then you can graph this and look for a relationship between the launch angle and the range. Specifically, what launch angle gives you the greatest range. Then when you're finished that and you make your graph, you can fill out your conclusion right here, and then you can turn your project in. Down below over here, if you're interested, is the rubric where I will assign points for each of the various components. And you can take a look at that after you've turned it in and you got it back, so you can see if you missed any points where they were